So again, one more brief introduction. My name is Jamie Scherer. I work on the Fusion 360 customer success team. Long-time designer, been with Autodesk about 8 years, ready to jump in and focus on what do we do with our generative results. So if you're new to Fusion, hopefully in this last update, you had a chance to preview the incredible power of using the generative design workspace to come up with solutions that you otherwise may have never thought of, that meet the real world requirements that you have for your designs. But most importantly, once we have those results, how do we work with them? I think it's about time for us to jump in, so I'm going to jump over here and just introduce kind of the problem that we're going to work through today. So what you'll see on screen here is an end effector, and this robotic end effector is pretty common in manufacturing space. And what we wanted to do was figure out how do we consolidate the parts that are a part of this gripper, but more importantly, make sure that it's lighter and that it performs at least as effective as it did previously. So I'll go through and just introduce you to the problem over on the Fusion 360 side. So again, in the last update was the release of generative design inside of the Fusion 360 canvas. And what you see here are the boundary conditions, the preserves, obstacles, and the starting shape for that problem or that design that I introduced before. So you'll see all of the areas in red are the obstacles. These are the areas where we absolutely do not want geometry. That would be, maybe our fasteners. That might be areas where we need clearance for other parts of the assembly. Again, obstacles, red in this example, in the generative workspace, are where we don't want geometry. The green areas are our preserve regions. This is where we absolutely have to have geometry. So we know we need geometry around the fasteners. We know that we need geometry at the ends of the gripper, where we kind of want to grow the geometry from. And that mounting location on the center, where you see the bolt pattern, is another area where we know we need to have geometry. And then the yellow area is the starting shape. This was, kind of built out, again, modeled inside of Fusion 360 to start to point our solutions in a direction, right? So it's not enough just to have the preserves and obstacles all the time. We want to sometimes give it a set of bounds that we want it to start with. Doesn't necessarily mean that it's going to stay inside of that shape, but it's going to give it a good direction as it starts to develop some of the results. So let's look at the result. You'll see here this is one of many different solutions that we got and ultimately decided to download from the generative design space. The most important thing that I want to point out is if you look down in the bottom left-hand corner, you'll see a timeline. Now, a timeline for something that we didn't create, something that was generatively created, will automatically appear when you download the results from the generative design workspace. But most importantly, you'll see for all of the areas in the middle are going to come in as T-spline geometry. So if we double-click on the sculpt object in the timeline, and we'll just edit it, you'll see that I now have editable T-splines that I can begin to work with. And most importantly, now I might want to start to get a closer look at the results that I got. Maybe there's some areas that I want to make changes to. Maybe there's some areas that need to be smoothed out, or ultimately I want to repatch. I have some holes in the results that I might not be happy with. I can patch those, remove them really easily, and then most importantly, remember that I'm doing this in time, in the timeline, so that any of the results or any of the changes that I make in this space are going to update my solid that we were looking at just a minute ago. So the first thing that I wanted to do, and again, for some of you, T-splines might be completely new or a foreign concept. Let's just talk a little bit about, what I call the anatomy of a T-spline. What is a T-spline? What are the different, types of geometry in this space, and how do we work with them? So what you'll see in Fusion 360, in the form or sculpt environment, you'll find faces. Faces are these, kind of four-sided patches that you see me selecting now. Edges, Edges are the boundaries on the sides of faces, and vertices, which are the intersections of edges. And faces, edges, and vertices can be manipulated, can be changed in concert with one another. And there's effectively 3 simple ways that you can edit a face, edge, or vertice. So if I were to grab these 2 faces in the Sculpt workspace and go to Edit Form, you'll see I can manipulate or move a face, edge, or vertice. I can take faces, edges, or vertices, and I can scale them. So under Edit Form, if I wanted to grab any set of these, you see I can scale up those faces or scale them down, which ultimately will bring them closer to each other. I can scale them along an axis, and you'll see, it's easy for me to scale them in one direction or another. Oops, in this case, scale them way bigger than I expected. And last, I can rotate faces, edges, or vertices. So if I were to grab, again, the same selection and go back into Edit Form, you'll find I can grab the little circular balls along an axis and twist them, right? Rotate them. I can do the same thing with faces. I can do them, with edges, or I can do them with vertices. These are the real fundamental, simple ways that we edit T-spline geometry, sculpted geometry, inside of Fusion 360. Now, what I want to talk about first, you'll see in this result, I'm just kind of, hopefully not gratuitously rotating this, but if you look at the side of this strut here, there's kind of some imperfections, right? You'll find that it's not perfectly smooth. There might be some areas that, I'm not happy with. I want to make some changes to. Now, again, as a quick sidebar, when we're working with generative design results, we're solving for additive manufacturing, subtractive manufacturing. So either would be fine. And maybe we don't mind that there is kind of this, uneven topology that's giving me, a little bit of a ripple on those struts. But if you're like me, you want to fix it. And if you're just a sculpt environment or a product designer that's here because you want to learn how to use the sculpt environment, well, fantastic. I'm going to teach you how to refine and start to make simple edits to this geometry so that you can get better control over the results. Now, the one thing that I'll do, I'm going to jump back, and hopefully you guys can see me again. We're going to turn off the banner here. Let's just talk really quickly about why we see those wavy results. It seems simple, but if you think about it like this, if we have 3 points on a curve, we would have less geometry, less math, and in most cases we'd have a more uniform kind of simple curve. But what we're getting with these results from the generative workspace is more and more edges, right? And if those edges or those vertices are slightly, not in line with each other, not along a perfect curve, what you're going to see is going to be slight imperfections, slight waviness, right? Because we have a lot of math, we have a lot of edges that are along that strut, and if in this case each one of them is not perfectly in line with the other one, we're going to start to see that type of waviness. Now, if we were to magnify that even more, right, and I'll add a lot of points on this curve, well, now we're just playing connect the dots, but hopefully you get the point. The more and more math that we have, the more and more edges that are along one of those struts, the more complex it's going to be, and ultimately the harder it's going to be to maintain kind of smooth continuity. So let's talk about some of the things that we can do. So the first thing that I might do when I'm looking at this strut is, maybe I'll just start to simply make some selections and remove some of the edges. Now, I'll clue you in, if you're new in the Sculpt workspace, there's a bunch of great selection tips that I'll be doing. Might even be hard for you to see, so I'll try to introduce them first. In the Sculpt workspace, if you double-click on a face, it'll grab the entire body. So simply, if you want to grab all of the faces, all of the math as a part of that body, just double-click on any face and it'll grab everything. Just the same, if you double-click on an edge, it'll grab the entire edge loop, which means in this case, you'll see that this edge terminates here on this star point and runs all the way through the end of this strut until it reaches another star point at the end of this geometry. So really helpful tool. You'll see me constantly just kind of double clicking on edges. And in this case, I'm going to double click and grab a bunch of these profiles. And we're going to do this just as a quick exercise to see what happens when we make some simple changes to the topology and what does it do to the result that we had before. So I'm going to grab those edges, I'm going to hit delete on the keyboard, and you'll see instantly, there it goes, instantly the T-spline is automatically updated, right? It's one of the beauties of working in the Sculpt workspace is that it always maintains G2 continuity, which means that the transitions between the faces and edges are always kind of perfectly smooth. No seams, they stay perfectly continuous. But just the same, as you have more and more of those edges in really close proximity to each other, you're forcing it to make big curvature changes in a small space, which is where you start to see some of that chattering or that kind of unsmooth edge that we had before. Now maybe that's not enough. I can continue and just kind of reducing the amount of edges that we have here. I'll delete them, and again you'll see further still this will become even smoother. Now the distance or the change in shape between these two edges are no different, right? You can see that in this case, they're not perfect circles, which is okay because we're creating something that we know we're probably going to, print, on an additive printer. But those two profiles haven't changed. The amount of spans or the edges that's between them is only one, where before we might have had 3 or 4, which was causing it to have, lots of imperfections across that span. So just by deleting some edges, whoops, and we will try to get that so it's not in our way, you'll see this is already quite a bit smoother than it was before. But let's look at some other techniques, right? So deleting edges and having it automatically resolve for you is a great technique. But, let's try something else. So we can also come in here and grab all of these edges, all these faces, and perhaps we and I'm going to make sure I don't select over here. I want these faces to stay. I'm going to keep a nice edge loop on this side, and there we have it. So let's take those and just delete them. So once I do that, now I can start to work. Oops, let me try that again. Apparently I got a little overzealous with my selection techniques here. So again, once I make my selections here and just grab all of the faces that I want to delete, you'll see that they'll automatically be terminated. And now I can work with these two edges, these two open edges, and perhaps bridge between them. And then you'll see I'm apparently having mouse troubles today where I'm selecting more than I want. So let's just undo that one more time. Control Z on the keyboard. Let's get back in a perfect kind of left view over here. There we go. And I'll make sure to be a little bit more careful this time and just grab the transitions that I want. All right, so now that I'm grabbed and hopefully deleted just the ones that I want, again, I could have kind of fixed those or patched those edges. For simplicity's sake, I just want to leave kind of these two open edges. And I'll use a tool now inside of the Sculpt workspace called Bridge. Now you'll find Bridge under Modify about halfway down. And simply what Bridge allows us to do, just like the name kind of implies, is bridge and ultimately create faces between sets of open loops. So in this case, I've just grabbed the two open edges that I've deleted, and I'm going to reduce this to one face, right? I want just one span between those two, and I'll hit OK. And the result that we should get is now going to be even further simplified. Right? Now what we have is, a nice uniform set of faces that's running down that strut, and we've effectively removed almost all of the chattering, right? Or the the waviness that we had because of the slight tiny imperfections between the faces and edges. All right, so we've talked a little bit about what a T-spline is. We started to talk about some of the selection techniques, and I showed you how to use Bridge. Let's go over to one of the other struts, and let's dig in a little bit more to some of the other ways that we can edit our T-spline geometry. So we'll use this strut right here. This strut you can see runs and kind of terminates against our preserve regions. If you were on Aaron's generative live stream just a couple weeks ago, he talked a little bit about what this is. Now, what's happening when you create, or when Fusion automatically creates the B-rep geometry, B-rep being solid geometry, in the Sculpt workspace, what it's doing is it's actually freezing those first set of edges, which is why they're colored blue, right? You can see the edges have blue on them. In the form or Sculpt workspace, you'll find that when the edges are blue, they're frozen. And what that means is that any of the changes that you make are not going to affect those edges, right? We're effectively saying, this I want to maintain. And the reason it's doing that is because if we start to pull these edges off of the solid, then we'll have a hard time automatically turning this back into a solid when we're done. Now, we could unfreeze that. We might want to make changes or change that shape. Not a problem. We can unfreeze it later. But just know that you'll find anywhere where the T-spline geometry touches up against a solid preserve, they're going to be frozen. The next thing that I'll talk a bit about, and we'll dig a little bit further into what we have here and some better ways to to work with this geometry. So my favorite thing to do when I'm in this workspace is work in box mode. I'll keep kind of referring to it as box mode. You'll find under Utilities, under Display Mode, there's 3 different ways that Fusion will display T-spline geometry. And it's by, it's smooth mode, which is what you're in by default. And the other option is to take an object and put it into the box display. Box mode, as I like to call it. And what I love about box mode is it kind of shows you all of the warts. It shows you all of the imperfections that you have in your model and really gives you a better idea of why you have some imperfections. So if you look at the topology of all of these edges, you'll now really get a sense for how much those little imperfections, tiny changes in each one of those vertices plays into the overall smoothness, if that's a word, to the smoothness of that shape. Now, if we were to just compare that really quickly, I'm going to go ahead and create a work plane. And I'm going to talk a lot about this here in a little bit, but I'm going to create a 3-point work plane just to put a work plane here on a plane so that I can extrude a new T-spline cylinder alongside of this. And I'm doing this again as hopefully what's a good display of the difference between what we're seeing in box mode and what a perfectly smooth T-spline would look like. So we'll go ahead and just extrude a new cylinder. I'm going to add in a similar amount of edges here just so that we have kind of the same topology. And if I were to grab this cylinder and I'll hit Control-1 on the keyboard, which is the shortcut for box mode. Now look at the difference, right? This is, in this case, there's 8 faces that break up this cylinder, which when you're in box mode will make it look like a perfect octagon, but that's what perfectly smooth would look like in the box display. When you contrast that with what we have over here, hopefully it makes a lot more sense now with why we have so much imperfection, right? Why we see all of the slight imperfections in our T-spline geometry. So let's get rid of that that new body for now. And let's talk about some other techniques that we can use to kind of arrange or refine the edges and vertices that we have here in this strut. So there's another technique that I love to use, and it's, well, first we'll talk about a great selection technique. So I mentioned before, double-clicking on an edge will grab an entire edge loop. But sometimes you don't want the whole edge loop. I don't want to effectively grab that whole edge loop down the entire part. But new, a couple releases ago, is the ability to select an edge, hold Shift, and double-click another edge, which will select all of the edges between kind of point A and point B. So this is another awesome way to, not have to spend a painstaking amount of time selecting every one of those edges, but just saying, from here to there, I want every one of the edges in between. Now there's a technique that you can use in here, again, under Edit Form. Edit Form in the Sculpt workspace is kind of your go-to. It's the tool that you're going to use to make all of your edits, all of the changes to the geometry. Now, another tool that I might use is the Scale tool. And you'll see with that edge selected, if I scale that up, it's gonna continue to stretch the faces there. But if I scale it down to 0, it'll kind of flatten some of those out. But you'll find in some cases, especially with the sculpted geometry, you might still not be able to get complete control over every one of those edges. I still have a couple peaks over here. So here's a technique that I love to use, and it's a combination of using the Flatten tool inside of the Sculpt workspace and creating some work planes that we'll kind of strategically use to flatten out the edges and vertices of this strut. So again, inside of or under the Construct menu, I'm going to create a plane through 3 points. I did this quickly before, but now we'll talk about why and how I'm using this. So I'm going to just create a work plane that cuts right down the center of this strut. And I'm doing that just by selecting 3 points, 2 on the top and 1 on the bottom. And you'll see that that work plane will now cut right through the length of this strut. And then I'm going to do the same thing. We'll create another work plane. And this time we'll do it through the other direction, I guess, the cross section, if you will. So just grabbing 3 points, kind of making sure that they're. In this case, we have 8 edges that make up this strut, so it's pretty easy for me to create a plane. And now I have 2 work planes that cut through this strut in both directions. A little bit of prep here, but you'll see how much easier this is than manually going through and maybe selecting faces and edges and trying to get them in line with one another. All right, so I'm going to do the same technique we talked about before. I'm going to grab one edge, I'm going to hold Shift, and I'm going to double-click the next edge. And the reason I'm pre-selecting that edge is because the Flatten tool, which you'll find under the Modify menu it's been a while since I found it in the menu, about 3/4 of the way down, you'll find Flatten. And the nice part about pre-selecting those edges first is that you don't have to now go through and select every single vertex. You'll see with something like the geometry from the Sculpt environment, it's going to be probably pretty heavy with vertices. So you might see a little bit of, circle spinning pinwheel as it thinks about all those edges, but at any rate, we're ready to go. So by pre-selecting the edge, I don't have to do anything else. But what I'm going to do now is first, I'm going to make sure that all of those edges are flat on this plane, right? I won't assume that they are. So what I'm going to do is select that plane, and then you'll see the Flatten tool has a couple different options. First, it allows you to either fit all of the edges together, which will just kind of average them out. It allows you to flatten all of the edges to a plane or parallel to a plane, and we're going to do both. So first, I'm going to flatten every one of those edges down to the plane that I selected, and we'll hit OK. I think most of them should have been pretty close to in line with that. Before I repeat the Flatten tool, just like I mentioned before, I'm going to pre-select those edges again, just so I don't have to grab every one of those vertices. So we will grab one edge, hold Shift, and I'll just zoom in here to make sure that I can get the edge that I want. And back to Flatten. And then this time, what I'm going to do is flatten out these edges parallel to the plane that I selected before. Now remember, I created that plane purposely so that it cut right down the center of this strut. Now this seems like maybe a bit of work, but remember, if it's really important for you, whether it's a generative result or just something that you're sculpting otherwise, this Flatten tool is great to help you kind of get all of your edges, all of your vertices in line with one another. So this time we're going to flatten that down to this other work plane. I'm going to let that show the result. You'll see what it wants to do with the select plane selected is take every one of those vertices and move them all the way down to the work plane. But I'm going to tell it to flatten them parallel to the work plane that I selected. And now you'll see it'll kind of average them out parallel to that work plane. And if we zoom back in here, again, a little bit of work, but now you'll find that that first edge is rather straight. It's much more in line with one another, and it'll give us a chance to really start to refine and ensure that these edges are not out of line with one another, so that we have that wavy surface. So I'm going to do this twice more. Again, you'll start to get the idea of what I'm doing here. I'm not going to do it, nor would I suggest that you do it for every vertice inside of your generative results, only if you need to. If it's important, then this is a great technique that you can use to flatten them out. So same technique here, flatten parallel to one plane, and then I'll reselect my edges here, and then we'll do the same thing, and we'll flatten it parallel to the first plane that we created. I see some questions coming in. I know Aaron is on here answering them for you. Thanks, everyone, for spending the time with me today. There's some questions in languages that I unfortunately can't read or speak, so I'll let Aaron answer all of those ones for you today. So again, same technique. Select the work plane, and then we're going to flatten that one out and say OK. And now if we just zoom back in here, I'll shut off the construction geometry that I created so far. You'll already see that we have much better continuity across those faces, something that I might want to continue to do along the way. But there's another kind of quick tip that I'll share with everyone, which hopefully will help out here. So if you're familiar with the Sculpt workspace in Fusion, there's a set of tools called Symmetry. And Symmetry, just like the name sounds, will make objects symmetrical to one another. Now, it won't work for this entire model because I can't put symmetry on such an asymmetrical shape. But in the case of just this strut, I might want to use Symmetry as a tool to force symmetry on the right side and the left side of the strut that I started working on. Maybe save me some time from going through and flattening out all of those vertices. So here's a tip that you can try out. So what I'll do is select one face, hold Shift, double click the next, which will grab a face loop around an object. I'm going to delete one side of, one loop, and then I'll come down on the other end, and I'll just grab the same set of faces there, delete them, and effectively what I did was sever this strut from the rest of the object. Now the reason I did that, if I were to try to create symmetry of that strut while it was a part of the entire other body, it would fail. It would tell me it can't do it. But if I try now with circular internal symmetry, and all I really have to do is grab a face on one side, and in fact I'll do it with, let me try that again. We'll do it with this edge here. You'll see that Fusion automatically suggests that this face is a possible symmetry, right? Or a possible face that could have symmetry with the other, which is great. So what I'll do is say that those two are in fact symmetrical to one another. And whoops, looks like I ended up with a twist here, which we don't want. So we're going to run that back one more time. And we'll do it with maybe the faces on either side of each other. The point being, what I'm kind of forcing Fusion to do is give me symmetry amongst these objects and save me a bit of time between, flattening out all of the edges of the geometry here. Now, I think I might have to actually flatten out one more set of faces, but again, the goal here is to force some symmetry back into the object, similar to like I did before, where I deleted the body and then re-bridged the body. This is just another way that you can come in and rebuild some of the geometry that's not perfect, right? Not incredibly smooth, or maybe needs some work in the Sculpt workspace. Once you do that, you can use the same tool we talked about before, which is Bridge, and just bridge back in the two sides. So, again, as a quick example, I'll just go through and just for visual similarities, let's just put that back into box mode, and in the S tool. So if you're not familiar with the shortcut toolbox in Fusion, hit S on the keyboard, and then you can bridge. Search for a command. I'm going to bridge from one edge to the next. I want one span, just like, oops, let me do that again. From one edge loop to the next. And again, I'm just going to bridge one span across them. I'm effectively just building back in the connection to the other bodies, which will make them, all a part of the same body again, right? Effectively putting back together what I broke before when I went and kind of severed out that geometry. So I'm going to jump back over. I saw someone was asking where's the video in this feed. Well, here I am. Again, hopefully so far, this has been pretty helpful. We talked a bit, if you're kind of joining in late, we talked about, on this side, we talked about the anatomy of a T-spline. I kind of got my whiteboard going because it helps me think about the different things that I wanted to show today. We talked some about the selection tips that I mentioned earlier. So just remember, in the Sculpt workspace, if you double-click on a body, you can select the entire object. If you select a face, hold Shift, double-click another, it'll grab a face loop. If you double-click on an edge, it'll grab the entire edge loop. And the other kind of tip that I showed before was with edges, if you click one edge, hold Shift, click another edge, it'll grab all of the edges in kind of a sequence or along that loop. The next thing that I've been talking about are just some different refinement techniques, I'll call them. And I'm going to jump back into Fusion 360, and we'll go through a couple more examples. Now focused a little bit more on working with holes. How do we patch, fill different holes, and what are the good, better, best techniques that you can use depending on the result that you're looking for. So let's jump back in. All right, so let's kind of first grab our object, and we're going to go back into smooth mode. So the keyboard shortcuts, which I mentioned before, Control-1 for box mode, Control-3 for smooth mode. And looking around, so there's some really good examples here of some geometry that I may or may not want to go forward with. I've got some holes in the center of my part here. The first one that we'll take a look at patching will be this little hole up here in the corner. Now, based on the loads and constraints that I put together, this is fine, right? This is obviously an area where we don't need to have material, but for whatever reason, whether it's aesthetic, whether it's just because, it's a part of the assembly and you don't want something happen there, right? I don't know if it could be a hazard or otherwise. What we're going to do is remove it, and I'll talk about how and the tools that we can use to do so. So first, if I select any one of these faces, there's a new keyboard shortcut inside of the Sculpt environment. It's Control-H, and Control-H will grab a loop of faces. Basically, it'll grab all of the features until it hits a star point. This is also really helpful with something like one of these struts. If you grab an edge here and hit Control-H, it'll grab the entire strut. Basically runs down the geometry until it terminates on star points. Now, what's great about that is, as I mentioned before, if I were to grab a face loop, a face loop might run down the entire object. But if I wanted to just grab that strut, I would select one face, hit Control-H, and it'll grab the entire strut. Same thing happens with like the inside of a hole. So if I grab one of the faces, hit Control-H, and I'll also point out that in Edit Form, under Selection Options, you'll find the Feature Selection, which is the tool that I'm using. It's the keyboard shortcut is Control-H. So if you had nothing selected and you grabbed one of these faces and then hit Feature Selection, it'll do the same thing that I showed you before. Now, what's awesome about using this workflow is there's another new tool in this workspace called Erase and Fill. And Erase and Fill is like your one-stop shop for grabbing these, not only deleting the old faces, but adding new faces to kind of patch in the geometry. Now, this is a great example where the result gives me, a nice four-sided patch, right? I have 1, 2, 3, 4, and And on the other side, you'll see the same thing. I've got a really nice kind of four-sided patch on the other side, which is really important. It's nice to maintain them wherever you can, but it's not always going to give you that same result depending on how complex the geometry is. So let's come around to the other side and look at maybe a more complex example. So if we look right here, I've got two holes that are kind of connected right next to each other, and this is an example where maybe I want to fill them. And in this case, we're going to start off, I'll just grab, I'm going to manually grab, because I'm kind of being choosy here with what faces I select. Again, I can blow a hole back as far as I want, but I also want to make sure that we get enough geometry to remove and then ultimately allow us to patch later. So I'm going to go and just kind of selectively grab the faces that are a part of those two holes, and I'm just going to hit delete on the keyboard. Now, before we use the fill, the erase and fill tool, which is effectively delete and fill hole at the same time. Now, fill hole is the same result that we did before. If we were to use fill hole over here, and we'll just say, we'll double click these two edges and hit fill hole, we're going to get, a pretty dramatic star pattern in the middle. We're going to have a crease at the bottom that might be hard to work with. And I think same thing on the other side. If we were to use fill hole on this side, we're going to get something, even harder to work with, or ultimately something that's even tougher. You'll see we have multiple different faces that are coming together in different star points. You'll see very extreme kind of creases in the topology of this surface here, which again, if we're printing it and it doesn't matter, not a big deal. But if you're just working with T-splines in general, this is something that you want to avoid. So I'm going to leave this one here, and we'll work on the other side first and talk about some different tools that you can use to get better control over how you fill these holes or how you patch together T-splines in Fusion 360. So the first thing that I like to do when I'm looking to work and again fill in a hole and match the topology with four-sided faces as best I can is go into box mode. Box mode always makes it easier to kind of visualize and see what we're working with here. The next thing that I'll do is I'll start to line up and look at how many faces I have and what's the best breakdown for how I might bridge or manually build back in faces to rebuild this. So if we look at what I created, I've got 2 faces on this side, which maybe would nicely transition into these 2 faces on the other side. And fortunately, we have 1, 2, 3 spans and 1, 2, 3 spans going across it that I can work with to kind of rebuild back this geometry in this hole. So this is actually a really fortunate situation. I'm going to go ahead and use bridge again, and I'm going to bridge these 1, 2 edges into these 1, 2 edges. Important this time is I'm going to make sure that we span 3 faces across this new bridge that I'm creating, so that those 3 faces, 1, 2, and 3, will line up nicely with the other edges that I mentioned before, and we'll bring this back together and have a much better result than a star pattern in the middle or just whatever I get by using the kind of automated tool. So this is really the manual way, but it gives you a lot more control in the end. So the tool that I'm going to use now, you can see I bridged across those faces, but I have a hole. They're not connected to the other vertices that are on the other side. So what I'm going to use is a tool called Weld Edges. You'll find Weld Edges in the Modify menu, and I'm just using the S tool and searching for it. I also have it in my shortcut toolbox that you'll see there. Now, sorry, I said Weld Edges. Let's rewind back the tape. It's Weld Vertices. So my English is effectively not working for me today. So Weld Vertices is the tool that we're going to use. All right, let's jump back into it. So what I love about Weld Vertices is, again, it gives you a lot of control, and it's contextual. So the first vertice that you select will weld to the second vertice that you select. So I want to take the bridge and move it over to the original geometry. I don't want to suck the original geometry up to the bridge. I want to push the bridge back to the original. So I'm just selecting one vertice and a second vertice, and I'm going to do the same thing on the other side and just weld together the new vertices on the bridge with the old vertices from the hole that we deleted. And with just a couple clicks here, you can also window select and weld vertices together that way. Be careful, because you can, especially with the amount of geometry that we have here in my generative result. It's often really hard to figure that out. So sorry about that. I just lost where I was. Let's get back in it. There we go. So, oops, I think I'm on the wrong side. So coming back around, you'll see, now I just want to go back and weld together those last faces. I'm going to go through that final step one more time, and because I accidentally escaped out of it, and it's just weld first selection to second selection. So the first vertice moves to the second vertice, and we'll just do that here 4 times to make those selections. Got myself distracted by talking about what happens if you window select. It'll just weld together a bunch of unwanted vertices, and then you can either unweld them or undo. So just be aware of that. So once I finally get this kind of pulled together, we'll talk about the difference between this and effectively what I created on the other side. So in this case, I'm just kind of hovering over. I'm trying to awaken or find where that vertex is. You can always left click and hold, which often gives you a selection here. I'm just going to zoom around, and we'll zoom in a little bit more. I've got one vertex that's kind of hidden from view. There it is. Let's just zoom back in here, and we'll find that guy. There we go. All right, so now that I welded those back together, I'm just going to jump back into smooth mode, and let's see what that result that we created looked like. Now I have multiple bodies inside of this design, so you can't just Control 1, Control 3. You have to select the object that you want to make smooth, and then hit Control 3. But if we kind of zoom back out here, and if you can remember the original result, we've got much better result that I manually created in here than what we had previously. I'm just gonna rotate this around so we can see that highlight come across. Still not perfect, might take a little bit more time, but effectively much nicer than what we did on the other side, which was just manually do it. And if you look at the curvature here, you'll see, kind of just some really intense creases because of how we pulled that geometry together. So we're here to learn. We're here to work on this geometry. So I don't like that. I'm going to delete it. And we're going to do this one manually too, just to reinforce and maybe talk about one other technique that you might use in a scenario like this. So the other side was the easy side. The other side was the side where I had 3 vertices, 2 to 2 with 3 spans on either side. It was really easy for me to kind of pull that together. But on this side, I have maybe a little bit of a harder time making those changes. So the first thing I'm going to do, I'm going to just move back some of these vertices, or vertex. I saw someone mention the singular of vertices is vertex. That is true. I'm going to just move that back, give myself a little bit more space. Now I can better visualize what this patch might look like. Now again, I think I can see 1, 2, 3 faces on one side that could flow continuously into the 1, 2, 3 faces on the other side with 1, 2, 3, 1, 2, 3. So it might be okay. I might be able to pull that one off. I've got kind of a funny face over here. It is 4-sided, but might not be the best transition. But I could absolutely do that. The other thing that'll come in handy, if you have a scenario where maybe you have 2 faces on one side and 3 on the other. Bridge is going to always want to make you transition from the exact same faces on one side to the other, or multiples of one another. So 2 faces can bridge into 4, 3 can bridge into 6. It'll create T vertices, or a T intersection in those instances. But the other thing that you can do if that's not going to work for you is there's a tool called Insert Point. Now you can use Insert Edge, which inserts an edge, or Insert Point allows you to select along an edge and basically split that face between 2 points. Now, I personally love doing this because, again, it gives me a lot of control where I'll purposely split different faces so that I have a better transition. Effectively, I'm creating a T intersection on the other side, but this is a nice way to maintain that. But, as I mentioned before, I might just come in and start bridging again to fix this up. So we'll do a bridge between 1, 2, 3 faces, and we'll bridge that on the other side over to these 1, 2, 3 faces. And again, I'm going to do a 3 face span so that they'll match up nicely with the others. And similar to what we did before, a little bit of repeating, but now I would just go through and re-weld them back together. The last kind of quick example or workflow, I'm just going to undo this for now in the interest of keeping our time together to a nice, crisp, under an hour segment, I guess is what I'll call it. The other example I kind of mentioned before, you can use Insert Point to split some of this geometry. But the other thing that you can do is delete edges to match the one side to the other. So the combination of the two, maybe you have 4 on one side and 3 on the other. You can split, make it 4 and 4. You could delete and make it 3 and 3. So use those in conjunction with one another to maintain even topology. I love this quote. It sounds quite impactful or something like that. This was on our Facebook user group the other day, and I'll credit Anton for saying we were talking about T-splines, and he was sharing, what's some of the best methodologies to use when you're using T-splines. And his quote was, "Imagine that every line should continue into something," which sounds so beautiful, I guess, when you think about it. But really, that's exactly what we're trying to do. We're always trying to make sure that there's a continual flow across these faces. Every edge should continue, or every face should transition into another face. So keep that in mind. It's really a nice tip or trick that you should use when you're in this workspace. All right. So just jumping back into Fusion really quickly, I'll do 1 or 2 more undos here. Just get us back into the original state where we had the fill hole, and we'll leave it as so for now. The kind of final thing that I wanted to talk about here was, the importance of what we're doing in context of the timeline. So let's just jump backwards here, grab these edges, and we're back to the original state that it was before. But remember that everything that we have done so far is in the context of the timeline that was automatically created when we downloaded this generative result. Now, we might spend any amount of time kind of refining this. Maybe it's ready for print now, depending on what we're looking to do. Maybe we're ready to machine it if we kind of used 3 or 5 axis manufacturing constraints when we first created it. But what I wanted to point out is that since I edited the timeline, or edited the sculpted shape in the timeline, once I hit finish form, as long as I didn't make any edits that no longer make this a solid model, as in I pulled one of the faces off of the solid bodies, or made some other change that I didn't intend, everything should update and it'll come right back into a solid shape that you'll see here. I've even got my extra body that I've got floating out here in space that we used as a test before. So again, just to kind of focus, we're working in time we're making edits to this geometry. Anything that we do here, as long as we don't break it and make it no longer a watertight solid, it'll maintain its nature as a solid body. All right, so that's a quick segment. Hopefully you got a tip or two along the way. There's even several more that I wanted to talk about that didn't really get a chance to weave into the workflow here. I saw someone asked, are we going to cut this into bite-size segments? I think it's a great suggestion. We're working right now on some new kind of tutorials that'll be a much more comprehensive generative workflow. Imagine using this exact example, creating all of those boundary conditions, creating the preserve obstacles, understanding what are the loads and constraints that gave us this shape, and then working into the post-processing part. How do we make edits to it? How do we machine it or get it ready to be printed? So yeah, stand by. We're gonna hopefully make this into something that's much more usable, or in smaller segments. Also, this will live hopefully forever on YouTube, so you should be able to watch it back and cut back through some of those examples. So with that, I'm going to thank everyone. Watch for the next live segment that'll be coming up. Hopefully Aaron will be back and giving away some more goodies. I don't have anything great to give away. You can have my coffee mug if you want, but it's got my coffee in it, so I don't want to give it up today. So thanks everyone for spending the time today. Again, if you like these segments, just give us a like, leave us some comments, let us know if there's something that you would love to see us cover in the future. And with that, I'm going to sign off and thank everyone for spending